Okay, without any delays, let's start. Tim ate 36 cookies. That represented 75 of all the cookies, 75% of all the cookies. How many cookies were in the bag to begin with? So, percent problem. And we're going to do this. What color? Ooh, like a purplish color. Okay. Alright, so 100 goes here. Percent comes up, so nice because it goes automatically here. And we have to figure out if 36 is the part or the total number of cookies, and in this case it's the number of cookies that he ate, which represents part, and that goes over there. So relationship, none, not that I know of right now. So let's simplify this. Let's see, divided by you know what, I'm going to divide this by 25. If I divide this by 25, I'm going to get 3. And if I divide the bottom by 25, I get 4. Okay. So now, is there a relationship between 3 and 36? Yes, there is. It's a times 12. So at the bottom will be times 12 for a total of 48. So how many cookies were in the bag to begin with? 48. And that's the answer. And that's question 1. Question 2, how much is 300 grams in kilograms? Okay, let's do that. How much is 300 grams in kilograms? What do we know? We know that 1,000 grams is 1 kilogram. Okay, and we want to know how much is in kilograms. So we have, how many grams do we have? 300 grams. And we want to find out here. That's what we're missing. Okay, is there a relationship here? Obviously not. So I'm going to do something a little bit different. You might find it a little bit weird, but just to show you how this actually works. So there is no relation. I'm going to simplify this. Okay, so I'm going to divide 1,000 by 10. If I divide 1,000 by 10, I get 100. Right? 1,000. So I should actually write this. 1,000 divided by 10 will give me the 100. And what about 1 divided by 10? If I had $1 and I had 10 friends and I want to divide the dollar by 10 friends, they each would get 10 cents. So for this one, I'm going to use a decimal. Okay, so is there a relationship between now 100 and 300? Yes, it's a times 3 relationship. And here is a relationship as well. It's also times 3. And if I multiply 0.10 times 3, I get 0.3. And that's what 300 grams is in kilograms. Okay. Okay. Basically, I'm dividing it by 1,000. 300 grams by 1,000. Another way of looking at it is dividing 300 grams by 1,000. Okay. Let's see. What is 35% of 80? So this is an is of, so you can do an is of here. Have that written down. What is 35%? So I have a percent, 35 over 100. What is, so the what is what I need to find, and of is 80. Divide by 5, I think that worked, and that divided by 5 is 7, divided by 5 here is 20, times 4, and obviously the top is times 4, gives me 28. 14 is another, 14 is 40% of what number? Well, 40%, I love it when percent shows up because it's very easy. I don't have to think if it's part or total, it's just percent. 40% of what number? What number is the part we're missing? So it's, we have 14 is. So 14 is goes here. Of what number? Of what number means this one is the one that's missing. Relationship, none. Divide by 10, that's 4. No, that's not going to help us. Divide by 20. Yeah. If I divide this by 20, 40 divided by 20, I get 2. If I divide 100 by 20, I get 5. I can cross this out here because that's, I don't need it anymore. Is the relationship? Yes. Times 7. 35. And that's my answer. Tom wants to spend 60 Percent of his allowance in books, he spends $12 on books. How much money did he get as allowance? Well, okay, another percent problem. So percent problems, you know that 100 comes here. 60% goes here, and $12. So 60% of his allowance is actually $12. So we're trying to find out how much allowance did mommy and daddy give him. Well, relationship, none. Well, let's divide this by 10. If I divide this by 10, I get 6. If I divide this by 10, I get 10. Nice, easy relationship. Times 2. 20. So what was his allowance? 20 bucks. And out of the 20 bucks, he's going to spend 60%, which is $12. But this is how much he originally got. Mark can run. Oh, we did this in class. He can run 5 miles in 15 minutes. And we want to know how far he can run in an hour and a half. Well, I know this is minutes at the bottom and miles on the top. I can't write 1.5, guys, over here, because that would say 1.5 minutes, and that's not true. We want to know how much he can run in 1.5 hours. So we have to change 1.5. Oops, gotta change. 1.5 hours needs to be changed to minutes. Well, 1.5, or it's 1.5. So 1 full hour is 60, plus half will be 30. So that gives us a total of 90 minutes. So going back here, I'm going to erase this. I'll put it more 90. And there is a relationship, times 6. Times 6 on top, that gives us 30 miles. So in 90 minutes, he can run 30 miles, which is really fast, actually. Super fast. Way too fast, actually. Yeah. Next question. The ratio of boys to girls in Mr. Simba's class is 2 to 5. What percent of the class are boys? Well, the percent question, right? You want to know what percent of the class are boys. So, well, this is 100%. What percent means that this part on top is going to be empty. And what do we know over here? The ratio of boys to girls is 2 to 5. So 2 to 5 means that there are 2 boys. Out of how many in total? Well, remember, 2 to 5, this is 2 boys, 5 girls. In this particular group, there are 2 boys for every what? Every how many people? A total of 7. And that's the relationship that we want here. This is going to be tough. Is there a relationship between 7 and 100? No, there isn't. No, there isn't. So we're going to have to change 2 over 7. How are you going to say? Because we can't simplify. You're absolutely right. You can't simplify, but guess what? We can make this bigger. So I'm going to multiply 2 times 100. That's going to give me 200. I'll multiply 7 times 700. I'm sorry. I'll multiply 7 times 100. And that's going to give me 700. So now we have our new ratio. Remember, to change our ratio here, we don't always have to simplify. We can go higher. So here, what's the relationship here? There is one. How did this 700 become 100? Divide by 7. And how this 200, what's the relation on top? It's also going to be a divide by 7. So this is not going to be a perfect number. We're going to have 200 divided by 7. 7 goes into 20 about 2 times, 14. 6, 0 comes down. 7 goes to 68 times, 56. 4 left over. Let's add a decimal, see if it helps. Add a 0, bring that down. You get 40. 7 goes into 45 times, which is 35. And you know what? I don't think it's going to. So 5 left over. Let me bring another 0 down. 0 is going to be 7. So it's not to go on, but the answer is 28.57, or 28 if you round that, 28.6%. I rounded. I cut the 7 out and left it at 1 decimal place. 28.6. So 28.6% of the class are boys. Okay. So the trick here was knowing that it was there are 2 boys for every how many? For every 7. Okay, because the bottom number, remember, part to total. The part is the 2 boys, and the total is the 7 in the group. Okay. um, length of Mr. Cho's class is 24 feet. And the length of Miss Pink's class, who makes these names out, is 9 yards. Who's greater? By how many feet? So if it's in feet that we want the answer, I don't have to touch this one. Leave that as it is. But I have to convert this one. 9 yards, I know that there are, in 1 yard, there are 3 feet. So if I have 9 yards, how many feet would that be? Times 9 relationship. Times 9, so that means 27 feet. So I'm going to change this 9 yards and make it 27 feet. And Miss Pink's rooms is bigger, obviously 27. It's bigger than 24 bigger by 3 feet. Bigger. And I can't write bigger by 3 feet. Ta-da! Okay. Fiona walks at a steady pace of 4,000 feet. 4,000 feet in every 6 minutes. How far can she walk in 15 minutes? Well, on the other side, it's going to be feet here, and minutes at the bottom, and there's feet 15 over here. Oh, yucca. Let's see. No relationship between 6 and 15. No. So let's... Oh, there is one. If I do this, if I divide this by 2, I get 2,000. If I divide this by 2, I get 3. Is a relationship there now? Yes, there is. Times 5. 5. And on top, times 5. 2,000 times 5 will give me 10,000 feet in 15 minutes. Okay? Let's see. 40% of the class did not bring their sign test. Oh no, there are 30 kids in the class. How many brought their test sign? So some kids did not bring their sign test. So here is, I'll do it 2 ways. You go like this and set it up. It's a percent problem. 40% of the kids did not bring their sign test. 40%, and there's 30 kids in the class, and that's total. So let's find out how many kids did not bring their sign test. So is there a relationship between this and this? No, there isn't. But if there is, if I do this, I divide this by 10, I get 4. Divide this by 10, I get 10. Okay, let me just take this out so you don't get confused. There is definitely a relationship, times 3. Times 3. 12. So what does that mean? It means that 12 kids did not bring their sign test. How many kids are in the class? 30. So how many kids actually bring the test sign? 18 did bring. Okay. Another way you could have done it, just a straight method, so that it avoids a subtraction here. It would have been, if 40% did not, if 40% did not, that 60% did bring the test sign. And you could have solved it the same way. Okay. Divide this by 10, 6 by 10 is 10. Times 3. And on top would be times 3, you get 18. So 18 kids did bring the test sign, which is what we got here. Okay. So there's a faster way. Put the following order from least to greatest. Show your work. Yuck. Alright, so this one you have grams and kilograms. Pick one. Either change everybody to grams or change everybody to kilograms and then compare. So 18,300 grams, that's okay. 18.1 kilograms, not okay. 17,600 grams, that's okay, because I like grams. And 18.2 kilograms, that's not okay. So let's leave these two alone and change. We're going to change this guy over here and this guy. So how do I change from kilogram to gram? I'm just going to do one on the side here. I know that there's 1,000 grams in 1 kilogram. Okay. So On this side, grams on top, kilograms at the bottom. What do I have? I have 18.1 kilograms times 18.1. So I'm going to end up multiplying 1,000 times 18.1. And that's going to give me 18,100. So this is 18,100. Same thing here. If I put 18.2, that's going to give me 18,200. Okay. Now I can easily put this in order. This is number 1, the smallest. Number 2, the second smallest. Okay, I'm going to take that back. Smallest guy is this guy at 17,600. Then is this. Then is this. And then the biggest guy is that. So, but what did you need to do? You did need to change everything to grams. Okay, so that you can compare. It makes life easier. But okay, 45% of the kids like Coca-Cola, 55 like Pepsi. There are 280 students in total. How many more prefer Pepsi? Okay. Let's pick one. 55%. 55%. And let me write this again. Let's find out how many people like Pepsi. So, 55% like Pepsi. And out of how many kids is this? This is 280 kids. So let's find out what does 55% represent. Divide by 5, you get 11. Divide by 5, you get 20. Is there a relationship? Yes, there is. Times 14. So it's on top is 11 times 14 as well. And 11 times 14, I have no idea what that is. 14, you get 14 and 14, 154. So 154 kids like Pepsi. Well, do I have to do the other proportion, 45? No, you don't. I know 154. So 280 kids total, 154 like Pepsi. So if I subtract 6, 2, 1 minus 126 like Coca-Cola. How much more is that? Well, let's see. 154 is the Pepsi. 126 is the Coca-Cola. Let's subtract this. 14 minus 6 is like 8. I don't know. 5, 4 minus 2 is 2. 28 more kids like Pepsi than Coca-Cola. Okay. I like both. With lime. John has a collection of 20 marbles. Here we go. 20 marbles. He has 20 marbles. 1/4 are green. Okay, what is 1/4 20? Well, if I have 20 and I break it up into 4 parts, I'm going to have 5, 5, 5, 5. This is 20. Broke it up into 4th. What do I know? I know that 1/4 are green. So 1/4 will be this group here. So I know that 5 are green. Okay, that was easy. 5 are green. And 60% are yellow. I don't know what that means. 60% are yellow. And I want to find out how many are green, which is the rest. Okay, something is wrong here. Okay, so this question, okay, so I'm going to write the question down here. And hopefully you will redo it because it's incorrect. John has a collection. Please has a collection of marbles. 1/4 are green. Okay, so let's leave that correct. 60% are yellow. Okay, and what it should have said is the rest are blue. And how many are blue? So this is the actual question. How many are blue? Okay. So 5 are green, 60% are yellow, and the rest are blue. Okay. So I have to find out what 60% is. So if I do my proportion here at the bottom, I have 100. I know that 60% are yellow. How many marbles do I have in total? 20. So what would be the relationship here? Simplify, divide this by 10 is 6, by 10 is 10, times 2, times 2. So 6 and 2 is 12. So 12 marbles are yellow. So 60% or 12 are yellow. Now, it's super easy. I know that 5 are green, 5 are green, 12 are yellow. So 12 plus 5 is 17. So those are my green and yellow marbles. And 20 minus, which is the total, minus 17, will give me 3 red marbles left over. Okay, sorry for the mistake here. Pound of apples apples cost $2.75. Sam bought 3 kilograms. Okay, so he bought 3 kilograms. How much does he get? He pays with a $20 bill. Well, first of all, I got to change because I don't know what 3 kilograms is in pounds. So if you look at your table, 1 kilogram, and I have no idea what that is, 2.2 something. Let me hang on a second. Press pause. So 1 kilo is 2.205 pounds, and that you have on that sheet you got the other day. That's my relationship. I want to go from kilo to pounds, not pounds to kilos, because kilos is what I have. I'm holding 3 kilos of apples. All right, so let's change that to pounds. So on this side, kilos on top, pounds at the bottom. So what do I have? I have 3 kilos. What's the relationship? Times 3, and also times 3 at the bottom. So as far as pounds goes, it's going to come out to 6.615 pounds. That's how many pounds of apples I have. Okay, 3 kilos or 6.615 pounds. I'm still not done. Okay, so now that's how much I'm holding in terms of apples right here. I need to go pay. So if I go to the cashier, she's going to charge me $2.75 for each pound I have. So I'm going to take the $2.75. Okay, and I'm going to multiply that by the number of pounds of apples that I have. Okay, and I am going to cheat because I am not multiplying that. I should. No, I shouldn't. Okay. Anyways, so if you take your calculator, which you might have access, I'm not too sure yet, 615, you're going to get, money-wise, if you multiplied all that, your final answer at the bottom should be 18.19125. Now, because we know money doesn't go that far, we're going to cut it right here. And it actually becomes 18.19. That's your total that you're going to pay. So, if you get cashier a $20 bill, you're obviously going to get some change back. Okay, 10 minus 9 is 1. I know this was a 9 minus 1 is 8. 9 minus 8 is 1. And change, $1.81. Okay? What is the sum of 1.2 meters and 12 inches in centimeters? Yuck. Alright, so 1.2 meters plus 12 inches. Can't really add these two as it is. We've got to change them to centimeters. We're going to change that to centimeters. Both to centimeters. Alright, so what do we know? I know that 100 centimeters equals 1 meter. That's on your sheet. Okay. So on top, centimeters, meters. What do I have? 1.2 meters. What's the relationship? Times 1.2. So on top it's going to be times 1.2. Okay, and that's going to give me 120 centimeters. So 1.2 meters in centimeters is 120. Inches. What's the relationship between inches and centimeters? 1 inch or 1 inch equals. Okay, bear with me. 1 inch in centimeters. So 1 inch equals 2.54. Okay, so 1 inch equals 2.54 centimeters. On this side, it's going to be inch again, in centimeters at the bottom. So what do we have? We have 12 inches times 12. I'm going to multiply this times 12. And I'm going to get a 2.54 2.54 times 12 equals 30.48 centimeters. So, and I'm going to replace that. Put it like this, 148. The 120 doesn't have a decimal, guys, so let me add a decimal in so to show you that my decimals are lined up. Add a 0 here and a 0. All my numbers are properly lined up. Place value, same place value under same place value. Let's add this up. If you add this up, you're going to get 8 over here, 4.051, 150.48 centimeters. So you definitely had to do some work here. Convert the meters to centimeters and the inches to centimeters. Okay. Last question. So a bathtub can hold 60 gallons. Here's a bathtub. Okay. Holds 60 gallons inside. Okay. There are currently 45 gallons. So 60 gallons, but it's not filled to the top, so it's at this level right here. And that's 45 gallons. How many more liters can we put in here? Well, to fill it all to the top, you're going to need 50 more gallons to fill it all the way to the top. So what's that equivalent in liters? Well, what do we know here? That 1 gallon, if you look at your conversion sheet, it's 1 gallon should be 3.7 something liters. I'm not too sure because I don't think too many people memorize that. So 1 gallon, 1 gallon in liters. Okay, 1 gallon, about 3.79. I don't know what the conversion is. It's not giving me 3.78. All right, so let's just use 3.79. 3.79. I don't know what your sheet says because I don't have that with me. 3.79 liters. Okay, 1 gallon is 3.79 liters. So if you need 15 more gallons to go all the way to the top, right? So you need 15 gallons on top here. Let's find how much liters would that be. So it's a times 15 relationship here. 15. And at the bottom is the same thing. It's a times 15 relationship. So you get 3.79. 3.79 times 15. That gives us 56.85 liters. Right, so that's how much. Really? That seems like a lot. All right, so that bathtub can still hold 56.85 more liters. So remember, it already has 45 gallons, but we need 15 more gallons to fill it all to the top. So 15 gallons in liters is 56.85. That's okay. That's about it. Hopefully you will watch this. Okay. Let's think of what am I looking at? Okay, here is your bonus word. Okay, that's it.